Hello my dear students, today I will discuss with you about the characteristics of periodic table. So let's start. There are 7 periods and 18 group in the periodic table. Here is 7 period and 18 group. 1, 2, 3, 4, 5, 6 to 18 groups. All periods starts with group 1 at the extreme left and extend up to group 18 at the extreme right. Starts from left and extends up to right. A small table of 2 horizontal rows and 14 columns displays the lanthanide and actinide elements beneath the main periodic table. Here this is lanthanide elements and here actinide, and this is actinide elements. These are part of period 6, 7 of the main periodic table. These are part of period 6 and 7 of the main periodic table. Period 1 contains only 2 elements. Period 2 and 3 contains 8 elements each. Period 4 and 5 contains 18 elements each. Period 6 and 7 contains 32 elements each. Period 1 contains only 2 elements. Period 2 and 3 contains 8 elements, that means lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Period 4 and 5 contains 8 elements. Period 4 and 5 they contains 18 elements, and period 6 and 7 contains 32 elements each. Period 6 and 7 contains 32 elements each. There are 18 elements and there are 14 elements. Okay. Group 1 contains 7 elements. Okay. Group 2 contains 6 elements. Group 3 has 32 elements. Group 4 to 12 contains 4 elements. Group 13 to 17 has 6 elements each. And group 18 contains 7 elements. Group 1 contains 7 elements. Group 2 contains 6 elements. And you see here group 3 to 3 has 32 elements. Group 3, this is group 3 and it has 32 elements. There are 4 elements and there is 14 and 14, 28 elements here. Okay, group 13 to 17 has 6 elements each. Group 13 to 17 each has 6 elements, and group 4 to 12 contains 4 elements each. Group 4 to 12, you see 4 elements. Okay, group 18 contains 7 elements. Group 18 contains 7 elements. 15 elements with atomic number 57 to 71 are called the lanthanide elements. Lanthanide atomic number 57 and 58 to 71 all are lanthanide elements. And actinide 89, you see here 15 elements with atomic number 89 to 103 are categorized as actinide elements. This is actinide, and 89 to 103 are categorized as actinide series. Physical and chemical properties of elements belonging to each of these two categories are so close that they have been put separately in two separated rows. Properties of elements change from left to right in the same period. Properties of elements change from left to right in the same period. The physical and chemical properties of elements of the same group are almost similar. Same group physical and chemical properties are almost similar. So we are going to next slide. Here we see the characteristics of group. Okay, then first, atomic size. From top to bottom in a group, the size of atom increases as a new shell to the atom. Okay, you see here hydrogen and you see francium. Hydrogen has 1 shell, lithium has 2 shells, sodium has 3 shells, potassium has 4 shells, rubidium 5, cesium 6, francium 7. So atomic size will increase when the size of atom increases as a new shell to the atom. See here, I am writing here. Here is hydrogen. So hydrogen have 1 shell, and here is I am giving the example of potassium. Potassium has 4 shell. 1, 2, 3, So atomic size is automatically increases here. Valence electron. Number of valence electrons in a group are same. Valence electron, that means outer shell electron. Hydrogen has one electron in its outer shell. Lithium has one electron in its outer shell. Sodium has one electron. Potassium has one electron. So number of valence electrons in a group are same. All elements have one electron in their outer shell. Potassium also have one electron in their outer shell. Valency. All elements in a group generally have the same valency. Valency is the power to gain the noble characteristics of an element. So, in a group, all elements have the same valency. That means this is the group of hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. This is group 1 and all the elements valency is 1. Hydrogen valency is 1, lithium's valency is 1, potassium's valency is 1. They have one electron and they want to gain the noble characteristics of noble gases. For this they will need one electron. For this their valency is 1. Metallic character increases from top to bottom in a group. Metallic character of these elements will increase from top to bottom in a group. You see here is hydrogen. So the hydrogen's one electron is near to nucleus, hydrogen's nucleus. But potassium, here you see potassium, its electron is far from nucleus. So this is potassium nucleus and its electron is far from its nucleus. We know that there is an attraction between proton and electron, and when electron goes far away from nucleus, their attraction will less. Then when attraction will less, so their power of to leave electron will increase because their attraction is less. So they can easily leave an electron. So when the atomic size will increase, then they can leave electron easily, and their metallic character will increase because we know every metal leave electron, and their metallic characteristics is for delocalized electron. So when elements go from in a group go from top to bottom, their metallic characteristics will increase. Electropositivity and reactivity of metals. Electropositivity is the tendency of an atom to lose its valency of electron and gain positive charge. The same characteristics of metallic character. Here, electropositivity means the power to become electropositive element or to leave an electron. On moving down the group, atomic size increases. So the valence electrons are far from the nucleus and the force of attraction between protons in the nucleus and valence electron decreases. Hence the elements down the group can easily lose their valence electron to form positive ions. Electropositivity and reactivity increases down the group. Potassium, metallic characteristics is potassium is greater than sodium and greater than lithium. We discussed it before for metallic characteristics. Okay, we are going to next slide. You see here electronegativity and reactivity of non-metals. Non-metals, who are non-metals? Here you see non-metals group. Non-metals group, which are non-metals? Here we see nitrogen, phosphorus, arsenic, oxygen, sulfur, selenium, tellurium. These are non-metals. Okay. Electronegativity is the tendency of an atom to gain electrons and gain negative charge. Is the tendency of an atom to gain electron. On moving down the group, atomic size increases. So the force of attraction between protons in the nucleus and electron being gained decreases. When the atomic size will increases, their attraction will decreases. Hence, the elements down the group have difficulty to gain electron to form negative ions. Electronegativity and reactivity decreases down the group. Example, fluorine, chlorine, bromine, iodine. For fluorine, fluorine has 7 electrons in their outer shell. Okay, 1, 2, 3, 4, 5, 6, 7. Fluorine has 7 electrons in its outer shell, and iodine also have 7 electrons, but its shell is 4. Shell number is 4. So in 4 shell it has 7 electrons. Okay. Two, 3, 4, 5, 6, 7. Okay, 7 electron. So fluorine its nucleus. So fluorine has from nucleus, from proton and electron, they have their attraction is more from iodine, because fluorine's first shell is near to nucleus, so positive negative attraction will be more. But iodine, their fourth shell is far from nucleus. Fourth shell is far from nucleus, so their attraction will be less from fluorine. For this, the characteristics of electronegativity is more of fluorine and less of iodine. Okay, then we can discuss about electron affinity. When radius will increase, electron affinity will decrease. Same thing, the radius of iodine will increase, so electron affinity that means the power of attraction of electron. The power of attraction of electron. See here is a electron. It is difficult for nucleus to attract this electron because it is more far from nucleus. But it is easy to attract one electron for fluorine because it is near to nucleus. For this, fluorine has more electron affinity. Ionization energy. When the atomic radius increases, ionization energy is less. That means ionization energy, that means when atomic radius increases, this atomic radius is increased and its ionization, that means to become ion. That means to become positive ion. Ionization energy, that means to leave an electron. When radius is less, then it needs more energy to leave an electron. That means for I think lithium's radius is less. It has 1 electron. So to leave electron from attraction, it needs more and more energy. But for potassium, attraction to leave an electron, it needs less energy because the electron is far from nucleus and their attraction is less. For this, it can easily leave the electron. Okay, we are going to next slide. Now I will discuss about characteristics of periodic periods. Atomic size. The atomic size decreases from left to right in a period. Along a period, with increase in atomic number, the number of protons and electrons increase. So there is an increased force of attraction towards the nucleus, hence the atomic size shrinks and decreases. You see, for lithium there is 2 shells and it has 3 protons and its outer shell have 1 electron. And for fluorine, It has 9 proton, but its outer shell have 7 electron. Its outer shell has 7 electron and it has 9, total 9 electron. The attraction between 9 protons and electrons is more than lithium, because lithium has 3 proton and 3 electron, and its its attraction will increase for fluorine. And for this, for force of attraction, fluorine's radius will decrease and lithium's radius will not decrease as like fluorine. For this, when we go from left to right, radius will decrease. Radius will decrease. Valence electron. The number of valence electron increases from 1 to 8 along the period. In first period, the increase is from 1 and 2 only. The number of valence electron will increase. Here, lithium has valence electron 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7. Their valence electron increases when it goes from left to right. Valency. Along a period from left to right, valency first increases from 1 up to 4 and then decreases up to 0. Lithium's valency is 1, beryllium 2, boron 3, carbon 4, but nitrogen's valence is 3, oxygen 2, fluorine 1, and for neon 0. Electropositivity and reactivity of metals. We see here when elements go from left to right in a period, their atomic radius will decrease. When atomic radius will decrease, their attraction will be more. For this, it is difficult to leave an electron. So when it goes from left to right, electropositivity and reactivity of metals will decrease. Electronegativity. From left to right in a period, the atomic size decreases due to the increase in nuclear force of attraction. So it is easy to gain electrons for non-metal atom. Hence, electronegativity and reactivity of non-metal increases along the period. See here is the electron, and for lithium there is the electron. Because of attraction, fluorine will easily attract an electron because it has 9 proton and its atomic radius is less than lithium. But lithium has 3 proton and its atomic radius is more than fluorine. For this, its attraction of electron will be less than fluorine. Fluorine will attract easily an electron. That's why in a period when it goes from left to right, the electronegativity and reactivity of non-metals will be increased. Okay. Electron affinity. In the same period, the elements of the left side have greater radius than those of the right side. When the atomic radius is less, the electron affinity is greater and vice versa. Silicon has least atomic radius and highest electron affinity than sodium. You see here, sodium's outer shell has 1 electron and silicon's outer shell have 4 electron, and silicon's proton number is 14 and electron number is 14, and sodium's proton number is 11 and electron number is 11. So silicon has more proton and its attraction of electron is more than sodium. For this, electron affinity is more than sodium for silicon. Silicon's electron affinity is more. Ionization energy. In the same period, elements of the left side have greater radius than the elements of right side. When the atomic radius is less, the ionization energy is greater. It's easily we can understand when atomic radius is less, then ionization energy is greater. When the shells is far from the nucleus, its attraction will be less and it can easily leave an electron. For this, their ionization energy is low. But when the atomic radius is less, then it is difficult for an element to leave an electron. For this, their ionization energy is more. Here you see the example. The ionization energy of silicon is greater than sodium, magnesium and aluminum. Sodium can easily leave an electron. Magnesium can easily, but it is difficult than sodium. But it is difficult for silicon to leave an electron. For this, the ionization energy of silicon is more than sodium, magnesium and aluminum. I think the students, you can understand my discussion. Okay, see you later. Bye bye.